Find the magnetic force for a 1 meter copper wire carrying 10 amps of current due east. Assume that the Earth's magnetic field is half a Gauss, horizontal, and due north. That's A. B. How does the magnetic force compare with the wire weight? Assume a diameter of wire of 2 millimeters. So for part A, I have sketched here the I for the wire going due east, and the magnetic force going due north, like this in horizontal. And in that configuration, as we saw from the previous YouTube, the magnetic force on the wire would be straight up opposite its weight. And that magnetic force would be IBL sine theta. I is the current, B is the magnetic field, in this case the Earth's magnetic field, and L is the length of the wire. So that works out to 10 amps times, so 1 Gauss is 10 to the minus 4 Tesla, and half a Gauss would then be 0.5 times 10 to the minus 4 Tesla, times the length of the wire, 1 meter, times the sine of 90, which works out to 5 times 10 to the minus 4 newtons. For part B, the first thing to do is to figure out what the mass of the wire is. And the mass of the wire is going to be the volume of the wire times the density of copper. Density of copper is a little bit less than 9,000 kilograms per cubic meter. The density is the area, which is pi over 4 d squared. D is 2 millimeters, 2 times 10 to the minus 3 meters squared times 1 meter. And that works out to 2.98 times 10 to the minus 2, I have the wrong units here, kilograms. And then the weight of the wire is the mass times 10 meters per second, again using easy numbers for G, which is 2.8 times 10 to the minus 1 newtons. And so the ratio of the magnetic force to the weight of the wire is 5 times 10 to the minus 4 divided by 2.8 times 10 to the minus 1, which is roughly 2 times 10 to the minus 3, small. Part C asks how much should the current be to allow the wire to levitate, in other words, to make this ratio become 1. Well, clearly the current would have to be increased by the reciprocal of this factor. And so 10 amps would become 10 amps divided by 2 times 10 to the minus 3, which would require 5,000 amps. And this would very quickly melt the wire. It's unrealistic.